Assalamualaikum. My name is Muhammad AZRI bin ISHAK. I will present regarding Cornerstone project for mechanical of solid 2 SKMM to 1 to 3. Our objective for this project is to design the project that requires stress and strain analysis and application of failure theories on a real life engineering structure. And our aim is to extend the student knowledge and understanding of the behavior of material and structure under variety of loading condition. The course start off with the plane stress, plane strain transformation, following with several elastic failure criteria and investigate. The course provide an opportunity to investigate thick cylinder structural deformation behavior by using energy method, instability problem of strut and elastoplastic bending of beam. We also can determine and any indeterminate problem will be examined. At the end of the course, students should be able to calculate and evaluate stress, strain, and deformation of structure in normal loading, torsion, bending, and they should be also be able to evaluate failure mode, estimate fracture life of structure and component. The aspect of designing safe component and structure will also be emphasized to the student. And we got four example problem, and here is problem number 1. If this is problem number 2 with a solid rod cylinder, solid rod. This is problem number 3, and this is problem number 4. It's an aluminium bar shown in the figure. And that's all from me. I will pass to next presenter. Thank you.
Hi everyone, my name is ZAID bin ZAINI. Today I would like to present my past on Cornerstone projects in Mechanics of Solids 2. So my past is problem 1. The equation are to write a computer program that can be used to calculate the principal stress. So I use OTIF to write a computer program. Okay, and the question to use this program to solve the following question. So this question are given the state of stress and angle. Okay, so I will show you how it be done on Octave. So this is my programming. Okay, and let's run the program. So input the value of sigma s. So based on the equation, sigma s is negative 60, sigma y 90, and the shear stress is 30. Okay, so just put negative 60 and sigma y 90, and the shear stress is 30, and the angle 25 clockwise. So 25 clockwise same negative 25. So that is the answer. So I would like to show you to compare with my manual calculation. So based on my manual calculation, I got negative 56.19 MPa for sigma, and the shear stress is negative 38. So if we compare to the Octave, it's got the same answer. Okay, so let's continue to the second question. Sigma s is 0, sigma y is negative 80, and the shear stress is negative 50. Okay, let's take a look. So I run. Sigma s is 0, sigma y negative 80, and the shear stress is negative 50. Just put it, and the input is 10 degrees, so positive 10 degrees. And the answer is normal stress and shear stress. Okay, if we compare to my manual calculation, my manual calculation got negative 19.51 and negative 60.65. So let's take a look. Okay, so it's got the same answer. Okay, that's all, and thank you everyone.
Assalamualaikum everyone. My name is Muhammad NAZIMIE bin Muhammad NAZMAN. Today I will present the Cornerstone project for the mechanic of solid 2. I will solve the problem 2 where this is a question and this is picture. So according to the question, we have given the following data. C equal to 40 mm, E 200 GPa, bending stress 250 MPa, R 40 mm. Thus, we have given this data by the question. Now we have to determine the bending moment, where the equation is M per I equal to bending stress per Y equal to E per R. So we find the moment of inertia, where the I we get 2.01091 times 10 or power of 6. Also, the distance from neutral axis y equal to 80 divided by 2, so we get 40 mm. Now we have all the values, so we put them into the above question 1, so we can get the bending moment m. So we get m about 12.566 times 10 of power of 6, and we also get m equal to 10.053 times 10 over 9. So the bending moment will be m equal to 10.053 divided by 10 over power of 9. So we will transfer the data into octave programming coding. So this is a coding. This is a result. So from this octave file, we can get the result. So we put all the input data in this octave programming, then we calculate it, so we get all the data, all the answer from this equation. So that's all. Thank you.
Here is problem 3. The steel rods AB and AC are made of a steel for which sigma yield 300 megapascal and E equal to 200 gigapascal. And this is the question. The steel rod, the length of 6 meters and 10 meter diameter, and a smaller one is 6 mm diameter. And there is load P given. And from manual calculation, we use from the formula, we find the maximum allowable force that will not cause permanent deformation. Find the volume of the rod in two parts for each increment. And the solution show the new total strain uniform cross section. And from the programming, I use the Octave programming coding. And here's some program for question A, and this is program for question B. This is a continuation for question B. And here result for question A, and this is result for question B, which is the highest and lowest value for total stress energy of the two-part section with L is 1 meter is equal to U 34.1 joule, and 6 meter equal to U equal 13.74 joule. For the highest and lowest value for new total strain energy for uniform cross section, for 1 meter is 49.48 joule, and for 6 meters is 106 and 0.3 and 0.03 joule. That's all from me. Thank you. Hello, Assalamualaikum. My name is Muhammad AZRI bin ISHAK. I will present on Cornerstone Group Project for Mechanical of Solid 2 SKMM 2123. From the result, after resolving the four problem above, we can say that solids are often defined as substance with securely bound atom or molecules, such as the crystal created below the melting point by the majority of substance or simple compound, and the amorphous structure formed in glass, and many polymer substances are sufficiently low temperature. Solid can be defined as substances that are not liquid. A material is described to as solid rather than fluid if it can withstand a sizable shearing force during the course of an intricate natural process or technological application. When under stress, a material rest shape diverges from its rest shape. Strain is the proportion of deformation to original size, where deformation is the amount of divergence from the rest shape. If the applied stress is low enough or the imposed strain is small enough, almost a solid material responds in a way that the strain is exactly proportional to the stress. The coefficient of the proportion is referred to as the modulus of elasticity. This region of the deformation is described as a linearly elastic region. And what we can say for the conclusion is that we are aware that solid mechanics is fundamental to many areas of physics, including material science and many branches of civil, aerospace, nuclear, biomedical, and mechanical engineering. It has specific use in a variety of other fields, including the study of living organisms, anatomy, and the creation of dental and surgical implant. The Euler-Bernoulli beam equation is one of the solid mechanics most widely used practical application. Tensors are widely used in solid mechanics to describe stress, strain, and their interaction. Okay, that's all for me. Thank you. Assalamualaikum.